Hello, I am Seema and welcome to part 1 of the chapter Redox Reactions. Do you know chemical reactions can be classified into different categories? Let us just remember what these categories were. The first type of reactions are the combination reactions. In combination reactions, you have small molecules which join atoms or molecules which join together, they form the reactants, and the product is a single product which is formed by the combination of the small atoms or molecules. So, combination means small particles joining to form a larger particle, or small atoms and molecules joining together to give you one product. So, if you have to identify a combination reaction, all you have to see is the number of reactants and the number of products. A combination reaction would always have more than one reactant, but the product would be a single product because that product has been formed by the combination of the reactants. The opposite of a combination reaction is a decomposition reaction. In a decomposition reaction, there is one reactant which breaks down or decomposes to give more than one product. So you have one substance which breaks down, it undergoes kind of a fission or a breaking and results in the formation of smaller particles. So if you have to identify one just by looking at it, not by looking at what the ingredients are, if you have just one reactant and more than one product, that kind of a reaction can easily be called a decomposition reaction. Then the third category of reactions was a displacement reaction. A displacement, displace, moving from its place. You've studied this in class 10. Displacement reaction is a reaction in which one substance or one ion usually takes the place of the similarly charged ion in another molecule. Now, for example, you go to watch a movie and your best friend is sitting on a seat and the seat next to him is occupied by somebody else. But you had planned to go for the movie with your friend. So when you go, you find that there is somebody else sitting on the seat next to him. So what would you do? You would request that person that if you don't mind, you please move here, take my seat and I'll sit there because you're also alone. You are alone, but I want to sit with my friend. So you displaced that person and took his place. Displacement means taking the place of another ion. So that is what happens in a displacement reaction. I will not go into details of this because you already are aware of these kind of reactions from your studies of class 10. If not, then I would encourage you to go back to that chapter we did in class 10 and revise it. After displacement reactions, the next category of reactions is a double displacement reaction. So you went for movies and you could not find seats together and with your friend, and there was another group of friends or a pair of friends who also went and they also took tickets, but they also could not find seats together. But it was coincidence that this person's friend, this person who's sitting next to you, your friend is sitting on that side. So that is your friend, then comes, that is your friend, and then next to him is the friend of this person who is sitting next to you. So what would you do? You will say, let's do one thing. Let that friend and me, let me come and take your place. You come and take my place. You'll sit with your friend. I'll sit with my friend. So what are you doing here? You're not displacing. There is a double displacement. That person also agrees to displace you here. He is taking your place in this pair and you are taking his place in that pair, and thereby making new pairs. So such an example or such a reaction would be known as a double displacement reaction. And then finally comes the last category, which is that of a redox reaction. As the name suggests, redox. Rid stands for reduction and ox stands for oxidation. Reduction and oxidation are two processes and they are opposite processes, and they always occur together, and therefore these reactions are known as redox reactions, reactions in which oxidation and reduction are occurring. And do you know what's interesting is that most of the reactions that you have can be classified as redox reactions. So let us start our study about this chapter of redox reactions. But before we do that, let us see where in real life do we see these redox reactions. I've written out a few examples as are given in your book. In the pharmaceutical industry, you often see reactions that are used in the pharmaceutical industries to make medicines, they use redox reactions. Many biological processes can be explained on the basis of redox reactions. Industrial processes like metallurgical operations, where you want to purify a metal and get it from its ore, we use redox reactions there also. For production of fertilizers in agricultural field, we again use redox reactions. Burning of fuels is an example of oxidation of the fuel. So they are definitely redox reactions. Electrochemical processes, all of electrochemistry that you would be studying in class 12. Electrochemistry is nothing but redox reactions, reduction and oxidation. So generation of electric current using batteries, using galvanic cells, all of these reactions that lead to generation of electric current are redox reactions. Extractions of metals and non-metals sometimes is done electrochemically or electrolytically. That is also a redox reaction. Chemical compounds like sodium hydroxide are manufactured by processes that can be classified as redox reactions. The operations of dry and wet batteries are examples of redox reactions. Metals get corroded, iron gets rusted, copper gets a green coating over it. All these are examples of redox reactions. These days we have fuel cells. In the Apollo mission, the fuel cell was used in which there was a constant supply of hydrogen and oxygen. And the hydrogen was used as a fuel and the oxygen was used to oxidize it, and it produced electric current. And as a result of this reaction, the oxidation of hydrogen and the reduction of oxygen, what happened, it resulted in the formation of water. And this water was added to the drinking water supply in the Apollo space mission, which was a very smart thing. And this is also nothing but the redox reaction. And since these fuel cells or batteries, they are environmentally friendly, therefore you would say that even in environmental studies, redox reactions are, in environmental areas, redox reactions are used. So much so that even the development of ozone layer or the ozone hole is an example of a redox reaction that has occurred in the atmosphere. So these are all examples of redox reactions. We understand that from this that redox reactions are very important and they are rampantly present everywhere in nature. Now, the question is, how do we define redox reactions? When I said redox reactions are nothing but two reactions occurring simultaneously, two opposite reactions, oxidation and reduction. So how do we define oxidation and reduction? Let us understand that. The first definition of oxidation, now there are 6 definitions that I have written out here. The first definition of oxidation is oxidation, the very place where it got its name from. Oxidation, addition of oxygen. It is getting oxidized. So oxygen is getting added to it. So any substance to which oxygen gets added is said to be oxidized. Right? The first definition would be that any substance to which oxygen is added, or we could say that addition of oxygen is defined as oxidation. Examples, you have magnesium. Magnesium combines with oxygen to give you magnesium oxide. Sulfur combines with oxygen to give you sulfur dioxide. Methane combines with oxygen to give you carbon dioxide and water, so carbon dioxide. So we find that in all of these, oxygen is being added. Therefore, this is the definition of oxidation. Addition of oxygen is known as oxidation. Then I told you that the opposite of oxidation is reduction. So if addition of oxygen is oxidation, then removal of oxygen should be reduction. So the opposite of this, that is the removal of oxygen, would be known as reduction. So in the first definition of reduction, we say removal of oxygen is reduction. That is, you have mercuric oxide. It decomposes. Now this is also a decomposition reaction if you really look at it. So it decomposes into mercury and oxygen. So it breaks down into mercury. What has happened? Oxygen has been removed from mercuric oxide. Therefore, it is a reduction process. What has happened here? Reduction of mercuric oxide took place by removal of oxygen. So that was the first definition of oxidation and reduction. Now, when this happened, I told you in the beginning that most of the reactions can be classified as redox reactions. But then all reactions do not involve oxygen. So how do you define? There should be other definitions not involving oxygen too. If you look at this example of methane combining with oxygen to give you carbon dioxide and water, not only is oxygen adding to the methane, simultaneously from methane, hydrogen is being removed, right? So it was found that any reaction in which hydrogen is removed would also be oxidation. So a second definition of oxidation was given, which was the removal of hydrogen. So removal of hydrogen is also known as oxidation. Example, you have one is methane. Second is you have H2S combining with oxygen to give you sulfur. Now see, from H2S, hydrogen is removed and the hydrogen combines with oxygen to form water, while the sulfur remains, turns into elemental sulfur or solid sulfur. So this process is also oxidation. So how would you define oxidation? Removal of hydrogen is also oxidation. So now we have two definitions of oxidation: addition of oxygen and removal of hydrogen. And the opposite should be the definition for reduction. So the second definition of reduction would be, if removal of hydrogen is oxidation, then addition of hydrogen should be reduction, because it is the opposite. So addition of hydrogen is known as reduction. You have ethene here, and if you add hydrogen to it, it gets, the second bond breaks and it turns into a saturated hydrocarbon, that is ethane. So ethene turning into ethane, what happened? Hydrogen got added to it. So addition of hydrogen is reduction, while removal of hydrogen is oxidation. Interesting. Now we had said that all reactions can be classified as redox reactions. And just as we said that not all reactions can have oxygen, similarly, not all reactions have oxygen and hydrogen. Then how do we explain that reaction to be a redox reaction, or how do we categorize it as redox reaction? To do that, we started studying the nature of both oxygen and hydrogen, and we noticed that in comparison to hydrogen, oxygen is negative in nature. It is an electronegative element, and hydrogen is an electropositive element. So why just limit yourself to oxygen and hydrogen? Let us expand it to other elements which have similar nature. So the third definition that was given of oxidation was that if oxygen is electronegative, addition of oxygen is oxidation. Therefore, addition of any electronegative element should be oxidation. So that is how the next definition of oxidation was given, that addition of an electronegative element this should be negative, I've written positive here, excuse me. Addition of an electronegative element, right? The addition of any electronegative element like oxygen. Now what are the electronegative elements? Examples of them: you have fluorine, you have chlorine, you have sulfur. So addition of an electronegative element should also be oxidation. And if addition of electronegative element is oxidation, then the opposite type of element, when we said removal of hydrogen, hydrogen is an electropositive element. So removal of electropositive element should also be oxidation. On the other hand, its opposite is reduction. Therefore, if the addition of electronegative element was oxidation, then removal of electronegative element will be reduction, and addition of electropositive element will be oxidation. So let us now see a couple of examples here. Addition of electronegative element, fluorine, chlorine and sulfur. We take the example of magnesium. To magnesium, we add fluorine to form magnesium fluoride, we add chlorine to form magnesium chloride, and we add sulfur to form magnesium sulfide. In all of these, an electronegative element is being added to magnesium. Therefore, magnesium is getting oxidized, right? If addition of electronegative element was oxidation, then removal of electropositive element should also be oxidation. Therefore, Removal of electropositive element is the next definition. Example, you have K4FeCN6 combining with H2O2 and it gives you 2K3FeCN6. Do you see, from K4FeCN6 you get K3FeCN6. One potassium has been removed, and potassium is a metal and it is electropositive in nature. All metals are electropositive. So removal of an electropositive element here would show that it is an oxidation process. So let us now come to the reduction side. Removal of an electronegative element is reduction. We said addition of an electronegative element like fluorine, chlorine, sulfur was oxidation. Therefore, removal of an electronegative element like fluorine, chlorine, sulfur would be reduction. So take a look at this example here. 2FeCl3 plus H2 gives you 2FeCl2. From FeCl3 you get FeCl2. One chlorine has been reduced in the molecule. Therefore, chlorine is an electronegative element. It has been removed. Therefore, FeCl3 in this case, it has undergone reduction. Right? And the next one is, the next definition here is that addition of electropositive element. Just as we had addition of hydrogen, which is electropositive in nature, therefore addition of electropositive elements to a molecule would be reduction too. So twice HgCl2 plus SnCl2 will give you Hg2Cl2 plus SnCl4. Now, in this you have Hg, that is mercury. Mercury is the electropositive element. And in this molecule you have only one mercury, and in the product you have two mercuries in the molecule. So in the molecule one mercury has been added, which is an electropositive element. Now at this point it is very important to tell you that we always call them redox reactions because they never occur alone. Oxidation never occurs on its own and reduction never occurs on its own. They always occur together, simultaneously. Now this is something like you have an apple and you give me the apple. Now I got the apple but you lost the apple, right? So you lost the apple. Let us say that apple is oxygen. So I gained oxygen, I got oxidized, but you lost that oxygen so that I get the oxygen. You had to lose that apple so that I get the apple. So removal of oxygen from you was reduction, right? So oxidation can never occur unless and until there is something which is providing that factor which oxidizes it. Similarly, if you had an apple and I was not even there, I did not even take the apple from you, could you get reduced? Could you lose the apple to another person? If you have to lose the apple to me because I have I'm your favorite. You will only give the apple to me. So now, unless and until I am present there to take the apple from you, you are not going to lose it. So you are not going to get reduced unless and until I am there to get oxidized. So oxidation and reduction cannot occur in isolation. They always occur together. If one substance is getting oxidized, the other substance automatically is getting reduced. Take any example in the equations that you have. Magnesium combines with oxygen to give you magnesium oxide, and we say this is getting oxidized. It's an oxidation reaction where magnesium is getting oxidized. But if magnesium is getting oxidized, oxygen is losing. Oxygen molecule lost its oxygens. So the oxygen molecule got reduced. Take any of these examples. Now I would encourage you to look at the board and pause the video when I just move out of the frame, and try to see in every reaction you'll be able to find if one substance is getting oxidized or reduced according to the definition, which other substance is getting, if one is getting oxidized, other is getting reduced, one is getting reduced, the other is getting oxidized. So you have to identify what is getting oxidized, what is getting reduced in each reaction. Let me step out of the frame for a moment, and there you can pause the video. Okay, So I'm moving into the frame again. So these were examples. Now, if you take this one example here, HgCl2 plus SnCl2 gives you Hg2Cl2. So the electropositive element mercury got added to this molecule itself. Therefore, this got reduced. At the same time, SnCl2, the other component, is getting oxidized. How? Because SnCl2 is turning into SnCl4. So by which definition do we say that this is getting oxidized? Cl, chlorine, is an electronegative element. So in SnCl2 you had only 2 chlorines, while in SnCl4 you have 4 chlorines. So addition of electronegative element, that is chlorine, is taking place in SnCl2. Therefore this is getting, SnCl2 is getting oxidized. So in this way you will find that in every reaction both oxidation and reduction are occurring simultaneously. Now, there are 2 more definitions of oxidation and reduction, which we will be doing in the forthcoming videos. So right now I'll just tell you what are the other 2 definitions. One definition of oxidation is the removal of electron. You know, when we said oxygen is electronegative, all these elements are electronegative. And what about electrons in an atom? Electrons are also negative. So why don't we just bring it down to the most elemental particle? So we say that the removal of electron, which is negatively charged, that is, the removal of electrons would be known as oxidation. And the addition of electrons would be known as reduction. Now, why do we say that removal of electrons is oxidation? Because when an atom loses electrons, it turns positive, it becomes positively charged. And that positive charge, when it turns positively charged, we say it has been, that positively charged form of that substance is the oxidized part, or it is the oxidized form. For example, magnesium, when it forms magnesium oxide, magnesium loses 2 electrons and oxygen gains 2 electrons to form magnesium oxide. So in terms of electron transfer, you would say that magnesium loses electrons, therefore it is getting oxidized. And the opposite of this, that is, when it gains electrons, that would get reduced. And here what did we say? Oxygen gained the electrons, therefore oxygen got reduced. So this was the next definition, and then the last definition would be the increase in oxidation number of an atom would show that it is oxidized. When you had a neutral atom or a molecule, its oxidation number is 0. So an oxidation number is the apparent charge. What is the charge on the atom? In magnesium oxide, I told you magnesium is 2 positive and oxygen is 2 negative. So magnesium from 0 charge becomes +2. It means its oxidation number increases. So magnesium got oxidized. And what about the change in oxidation number of oxygen, which got reduced? The oxidation number of oxygen molecule in oxygen molecule is 0. And in magnesium oxide it is -2. So oxidation number changes from 0 to -2. So the reduction in oxidation number will be reduction. Increase in oxidation number is oxidation. So these are the various definitions of reduction and oxidation. With this, I'll finish this video and we'll study more about the electron transfer, oxidative redox on the basis of electron transfer in the next video. If you found this helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.